Most DevOps engineers think system design is just for software architects. That's wrong. If you've ever been asked to build CI/CD pipelines, secure secrets, or even scale infrastructure, you're already designing systems. Now, today I'll break down exactly how a principal DevOps engineer thinks about system design using real-world examples and production trade-offs. Now, this is a video I wish it existed 5 years ago. So let's get started. DevOps isn't, like I said, running just pipelines or bringing in servers. It's actually designing systems that scale, that work, and that don't wake you up at 3 a.m. And here's the thing, most engineers completely skip this part. Now I'm going to walk you through how a principal DevOps engineer designs a real world system, from CI/CD to secrets to even monitoring, so you don't end up building a big monster that no one can maintain. Let's go. So as you can see here, right, we're going to start with the first thing. System design, for DevOps is actually about building that, invisible backbone that developers rely, on to ship, save code safely and fast. Now there's just a bunch of diagrams, so I'm trying to show you here what it actually looks like. So the first thing is, how quickly can a dev go from an idea to PR to production? How secure is the deployment flow? And what breaks if AWS has an outage, for example? Now we're not just solving for uptime, we're solving for developer experience, velocity, and resilience. Now think of it like this: if your DevOps stack was a product, would anyone actually use it, or would they curse you every single day? Now as you can see, a little sketch here, right? Developer makes a code change, a git commit, goes to a pipeline which gets built and tested, then the actual CD pipeline which deploys it. Then you might have your compute, could be a cluster, could be a Lambda, could be EC2, could be ECS, doesn't matter, that's the runtime, that's what it runs on, right? Then you have after that the observability, the aftermath, what happens after that, how do you monitor what's going on, right? Your alerts and so on. And there could be like a rollback strategy in case something goes wrong, how do you roll back? Now the idea here is to reduce the time between the developer pushing to production. That's the rough idea. Okay, if you move on now to the core components of this architecture, this system architecture, right? Here's a system you're actually quietly building as a DevOps engineer / a systems engineer / someone who's designing the whole architecture of DevOps. What it looks like, right, when you start from the code to the platform to the infrastructure. So the first thing you have, it will be the the source layer, right, where the code is. You Git platform and GitHub, GitLab, branch strategies, you design your pipelines and so on. This is very important. Your commit hygiene, you're not pushing secrets and so on. This is a very important part people tend to ignore. The next thing will be the the CI layer, setting up your pipelines. Whether you decide to use Jenkins or Circle CI or GitLab CI or GitLab Actions, that's up to you, right? But then this is also an important part. Having quality gates, linting, SAST, unit tests, and all these things are very, very important. Do you decide to use self-hosted runners? Do you cache your things? Do you parallelize your runners? Do you parallelize your runners? Do you make your runners parallel? Do you have caching? And how fast do you want to run? Are you having private environments? You want to avoid public runners? All these questions you need to ask. Then after that will be the CD layer, as we spoke about before. This is the actual deployment. Once your CI is done, the deployment part. It could be Argos, it could be Flux, right? Are you doing canary deployments? Are you doing blue-green, stage rollouts, and so on? Are you having different environments like promotion? Are you starting from dev to staging to not prod until production, right? You need to think about all of these things. Then there's the runtime. This could be the clusters, could be the ECS, could be the ECS that I spoke about, the actual infrastructure and compute you use. Again, you need to decide what this will be. Could be, do you want to have cheaper runtime? Are you running workloads every 10-15 minutes with a Lambda? Are you running consistent workloads? This is what you need to think about and ask yourself. Then you can move on to the secrets part. Secrets is a big part. Nowadays, hackers are looking out for every small mistake you make. You push a secret and that's it, game over. They have access to your whole database, your whole systems, and that's it. So you can using that vault, sealed secrets, SOPs even. These are very, important strategies to use for secret management and things to consider before you start creating your production workloads. And last but not least, metrics, observability, alerting, all these things are very important, and monitoring, right? Prometheus, Grafana, Loki, Alert Manager, these are all very important, right? You need to see your metrics. Where they go to, Prometheus is the most common one. See what's going on behind your applications, right? You want to see logs, system logs, your application logs, infrastructure logs, all these things are very important. And then Grafana for your dashboards is not here, but Grafana very important, so you can see what's actually happening behind the scenes, right? Where are the graphs going, right? Are you having drops in traffic and so on? And then alerts, right? You need to see what happens. If a system hits your CPU limit, you need to have an alert in place. You need to have PagerDuty, so if something goes wrong, you get alert and you get called out. Next thing is actually the infrastructure. Now let's say I joined a Series A, the fast growing hyperscale startup tomorrow, right? And they've got devs, they've got AWS, but no infrastructure. Where do you start? Now the first thing I would want to start is, I would, as an infrastructure engineer or DevOps engineer, I'll think about Using Terraform, right? Having my infrastructure as code, firstly design what do I need, right? Once I have that, I can use Terraform to actually design. I think about things like VPCs. Do I have to have landing zones so I can create multiple accounts? And all these things have to be, thought about. How do I create my VPC? Do I create 5 public subnets and 5 private subnets? Do I create multiple VPCs? Do I pair them? All these questions are to be asked and thought about. Then if I'm using Kubernetes, for example, do I create EKS cluster? Inside that cluster, what do I add inside? Do I have managed node groups? Do I have Fargate? Do I use Fargate? Do I use self-managed nodes? And so on. And within that, what do I add? Do I add platform commands like cert manager? Do I add external secrets, external DNS, and so on, right? These are very important questions to be asked. And then for load balancing and traffic entering the cluster, do I use Nginx? Do I use Trafic? And these things need to be asked and thought about. And then I can think about using GitHub and GitHub Actions with the CI/CD. How do I implement those things? Do I use reusable templates and so on? Costs. How do I monitor my costs? See what's happening in my infrastructure. How do I save costs? Right? Cost optimization and FinOps is very key and important. Now, once you design this, sometimes there are things that you learn from other people and you don't want to make the same mistakes. And these are things that I see very often. Over engineering. You don't need Istio from day one. If you don't need it, don't use it. Reusability, right? If you need to reuse something more than 3-4 times at the minimum, right? Make sure to have some sort of module system, right? A dry system. That means using the dry principles, not using the same thing again and again without actually making it into a module or something that can be reused. Very important, right? Not having RBAC in place. RBAC is very important because once you realize that your services have taken over and have elevated permissions, you are easily able to get hacked. Very important, right? And not having cost visibility, because how do you know if you're over provisioning services? You need to ask yourself that, right? This is very important. And everything that's running, but no one knows how or why. Now, a rule of thumb is that if a junior engineer can't onboard within an hour or two, or even a maximum a day, your system probably broken or is too complicated. Now, what I like to use as an architecture is that how do we know what a great system looks like? If a developer can onboard, or a DevOps engineer can onboard to your system with a single command, or following a few things just within less than an hour, like I said before, that means really good. Can your infra deploy via one pull request or merge request and GitOps? If so, amazing. Your secrets, they shouldn't be hitting local dev boxes, right? I don't want to see any of that. Use Vault, IRSA, seal secrets. Make sure you have the zero trust, right? Automate rotate your secrets. Make sure there's automatic rotation of those secrets. No pushing of environment files and none of that stuff, right? Now everyone should get observations that are asking, right? You should see metrics, logs, traces. People should see what's going on. Your Grafana dashboards, people should be able to see what's going on, so anyone can actually fix a problem. That means that people are not always scared to push a prod. If it's needed, they can do it, right? Canary deployments, and they are very managed, but at the same time making sure that it's controlled, right? Canary deployments, blue green. Are there safety nets in place? Can you roll back if something goes wrong? Now, if you've ever been overwhelmed by DevOps tools, right? Is not your fault. I don't blame you for this. You were never shown the whole system view like I've shown you right now. Now you've got it, right? I'll be doing more deep dives into each piece we covered: Argo CD, Vault, CI/CD, Terraform, Istio, all these things, right? Please hit subscribe, drop a comment below, what you want to see next, and even share with your team. Let's stop building that infra spaghetti and start designing real systems that can scale.